at a bond, it turns yellow, it fluoresces, okay? So as an indicator that the enzyme is working because the bond got broken. So if the solution turns yellow, what does that tell us? The enzyme is working. If the solution does not turn yellow, it tells us
The enzyme is not.
the enzyme is not working. That is what we're going to try to understand today. How does enzymes work under different environmental conditions? We're going to expose it to pH. We're going to expose it to salts. We're going to expose it to temperature. We're going to expose it to other sugars. Right? So we want to understand how does it react for bonding, and we're going to make some hypotheses of competitive inhibition or competition. So we're going to get familiar with this enzyme because we're going to use it a lot over the next few weeks because we're going to use lactase with lactose as our model. Okay, it's our experimental model because what you now know how to do is take these monomers to make dimers, to make polymers, to make a protein, to make an enzyme. That is what you should know how to do as of today. What we're going to do starting after the exam is we're going to start making the enzyme through transcription, translation, and we're going to start regulating it. Because if you understand how this one enzyme works from transcription all the way through, you can apply that principle to everything else. If you know how to make one, you know how to make them all. Okay? That's what the idea of this model is. So, it's a very simple experiment. Every one of these experiments are the exact same. We take 1 ml of ONPG plus 1 ml of X. X is a pH solution, sugar, milk, salt, temperature, whatever, okay? Add 20 microliters of enzyme and see if it turns yellow. That is it. Step one we're going to do is make our ONPG. We're going to give you powder and a brown tube vial. Okay, you're going to take this powder, you're going to stick it in here. You're going to add 20 milliliters of DI water. You're going to cap it, you're going to shake it for 10 seconds, and it's going to turn yellow. Why do we keep all reactions, reagents in brown bottles?
Light.
Light. We don't want them to be light sensitive.
Mm-hmm.
Light is energy. Energy will speed up the reaction. These reactions are spontaneous. They will go. The reason why I have you make the ONPG and we don't just make it as a stock and give it out is because the ONPG is typically only good for about 50 minutes. All reactions are spontaneous and it will occur. The ONPG will turn yellow if you just sit there. Okay? So we are putting it in a brown vial and we are making it ourselves so we can delay the reaction as long as possible, but the enzymes will do it a lot quicker. So what you're going to do is we're going to have somebody come up and grab one of these. You're going to make an ONPG and then grab a test tube rack in a dozen or so vials. On every one of these experiments, you're going to use a new clean pipette tip and a clean vial. Enzyme is really good at getting stuck in the crystallized glass. Okay, so once it's gone in here, this glass wort is no good. So we toss these immediately afterwards. If I put enzyme in here in 6 months from now, throw some ONPG in here, it will turn. Okay, enzyme is really good at hiding out. So that's what we're doing. So send somebody up, grab that. Life is good.
I'll grab one for the two of us.
Yeah, we're working in tables. So one per table.
Oh, one per table. Okay.
Yeah.
All right, got one for our table.
You know that the format complete reactions research is
So where's our first step? Making ONPG. Take the vial, put 25 milliliters of water into it, and add And shaking, sorry, that's powder.
Vial? Oh, take
25
a,
milliliters.
That's
So
a vial, right?
You can use a beaker
Oh, you got the one.
or a volumetric flask.
we need 50. We
So
need
what's the
25, so it would be half. I would be filling this beaker halfway with the eye water.
So our first steps, we're gonna be making our controls, so follow those directions. Oh,
Okay,
sodium
so we need,
bicarbonate is over here in vials. In
25
little jars.
milliliters of water. So
Sodium bicarbonate is caustic, so if you spill it on your clothes, it will stain. If you get it a little bit on your skin or something, wash it off. We're not super cautious around here.
Super safe.
5 mLs.
Looks like about 25 mLs.
Oh, okay, so,
Got 25 mils of water.
okay.
So what do we add it to this?
Let's see that one.
The empty tube?
Yeah, we add it to this thing. We add it to the empty bottle.
One vial plus 25 milliliters of water. Now your OMPG is made.
Alright.
Well, we need to
One
fill
vial, this?
That's a vial.
Sassy.
The amount of sass that comes from me is
Yeah,
pretty
you're a
remarkable.
sassy
So,
man, but it's okay.
would you have me any other way? Don't answer.
Sometimes we need the sass. Like, it's okay.
Don't like it, keep it to yourself.
Yeah, seriously.
Seriously?
I could be really boring and just stand around and or I just flip you shit nonstop.
Oh yeah, please don't do that.
Yeah, no, we don't want that.
You're like, I have